Hi there, my name is Dr. Marissa May. In this video, we're going to be looking at all kinds of symmetry. Now, I get lots of questions about this lesson, so I thought I would kind of simplify it a little bit. I've got a few bullet points to start out with before we jump into some examples. So one thing to think about is that rotational symmetry, an object has it if you can turn it less than a full circle and have it look the same. So this is, I want you to think about like rotating a piece of paper with an object on it to get the object to look exactly the same, less than 360 degrees. Second bullet here is that trapezoids do not have rotational symmetry. The only way to get the same image with the trapezoid is to rotate it a full 360 degrees. Third bullet here, regular polygons have equal sides and equal angles. So anytime you stick that word regular in front of a polygon, so regular triangle, regular quadrilateral, regular hexagon, just isn't telling you that now they have all the same side and all the same angles. And regular polygons are the ones that have rotational symmetry. The red one here is, I have it in red because it's really important, and that's to determine the degree of rotation, you need to divide 360 by the number of sides. We're going to look at an example of that. And the degree of rotation is, catch this word, the smallest increment that a shape can be turned to be back on itself. Now, of course, I've got some examples for us to look at, so let's do that. So what is rotational symmetry? So if you can rotate a figure less than 360 degrees, so less than a full circle around a fixed point, and you get the figure to look exactly the same, then the figure has rotational symmetry. You can tell this figure over here on the right has rotational symmetry because I could rotate it 60 degrees, and I could rotate it 120 degrees and I would get the same figure. I could rotate it 240 degrees and I would get the same figure. Now, I'm going to show you how we find the angle measures, but I want you to see that I actually could rotate this less than a full circle and get the same figure. So here are some regular polygons. We stress the word regular means that you are now going to have a polygon where all the sides are the same length. So if you have a regular triangle, we often call that a equilateral triangle. If you have a regular quadrilateral, we call that a square. You get the idea. These others just require we put the word regular in front, but what we're saying is just by putting the word regular in there, we get that all the sides are the same, all the angles are the same. Okay, so how do you find that angle of rotation? Well, the angle of rotation is the measure of the amount that a figure is rotated in order to get the same figure. So because I have a regular hexagon, I could rotate this 360 divided by 6, because there are 6 sides in a hexagon. I could rotate it 60 degrees. In fact, I could rotate it any multiple of 60 degrees. I could rotate it 60, I could rotate it 120, I could rotate it 180. You get the idea. But this is my formula that's going to help me know that angle of regular rotation for a regular polygon. Okay, so let's put this into action here, okay? So first of all, look at your figure. Ask yourself, is this a regular polygon? What does that mean? And what am I asking really? Do all the sides, are they the same length? Are all the angles the same length? The answer is no. This is a rectangle, so we have opposite sides are the same, but not all sides are the same. So could you rotate this less than 360 degrees and get this same rectangle? Well, let's try it. Watch the rotation happen. Still haven't got the same figure. I want this red one to land back where the green one is. Looky there. I do have an angle of rotation. I can rotate this 180 degrees and I get the same figure. 180 is less than 360. So yes, we say this has rotational symmetry and the angle of rotation is 180. Okay. It's not a regular polygon, which is why I didn't use the 360 divided by 4. Okay. All right, is this a regular polygon? The answer, no. Not all of the sides are the same. So it's not a regular polygon. does it have rotational symmetry? Well, let's check it. Can I rotate it and get back to that same figure? Can I rotate it so that the red and the green now land on the same spot? And again, the answer is yes. That angle of rotation is 180 degrees. Why didn't I use the 360 divided by the number of sides? Because it's not a regular polygon. All right, is this a regular polygon? The answer is yes, it is. All of 9 of these sides are the same. So if we use our formula, 360 divided by 9, I'm expecting this angle of rotation to be 40 degrees. Okay, let's check it with our slider here. We're rotating it to see if we get the same image. Looky there, we do at 40. Notice again, we would get it again at a multiple of 40 at 80. We would get it again at a multiple of 40, 120. You get the idea, okay? My formula, 360 divided by the number of sides, works because it's a regular polygon. Okay, what's the angle of rotation here? I didn't put a slider on this one. Well, it's not a polygon. We didn't ask that question, but we could have an angle of rotation and we would rotate it 90 degrees. You're asking, Dr. May, where did you get 90 degrees from? I'm so glad you asked. We got 90 degrees because there are 4 of these petals. I just need them to land back in the same spot. So I took the 360 and I divided it by 4 to get my 90 degrees. All right, reflectional symmetry. So reflectional symmetry happens when an object looks the same if it's reflected on either side of a line. In layman's terms, that just means, can I cut this figure in half so I have mirror images on both sides? I want you to think back to your algebra days. We talked about an axis of symmetry for a parabola. Could you cut the parabola in half? Could you write an equation for that line that would cut the parabola in half? We're going to do the same concept. We're just going to do it with polygons or with shapes instead of just parabolas. So how many lines of symmetry does our square have here? I want you to think about hamburger, right, and hot dog. Think about the different ways you could cut this square in half. You could cut it height-wise. You could cut it lengthwise. So that gives me 2 lines of symmetry, but then I also want you to think on these diagonals, right? You could also cut it along the diagonals and you would get mirror images on both sides. So I end up with 4 lines of symmetry there. All right, so if I now look at a figure on a coordinate plane, you see my hexagon A, B, C, D, E, F. One of the questions you might be asked to do is to write an equation for the line of reflection. So not only do you have to find the line of reflection, you have to notice it, but I would also then have to write an equation for it. Now, there are several lines of reflection here. So we're going to focus mainly on the vertical line of reflection and the horizontal. And I do just ask that you forgive my writing for the writing with the mouse today. I wanted to get this video out to you guys because I know some of you had some questions. So let's look at the vertical line first, okay? Notice that the vertical line is going to have to run through the middle of your figure. So I'm just going to draw it here. Okay, notice it's there. I also want to draw your attention that this vertical line is halfway between A and B, halfway between point E and D. So let's think about what are the coordinates for point A. Point A would be at 4, 4, 7. Okay, point B, its coordinates are at 6, 7. Okay, so halfway between these two would be at x equals 5. So I want you to make a note to yourself that vertical lines have an equation, x equals a number. And you can see that between 4 and 6 would be 5. Now, if you run into any like decimals that aren't as easy to read, I want you to see what I really did was I averaged the 4 and the 6. I added them up and I divided by 2 And that's how I really got 5. Okay, so if you can't visually see it, I want you to think about averaging the two numbers to make it a little easier for yourself. Okay, now let's look at the horizontal one, right? So we got horizontal is going to run this way. We know horizontal lines have an equation of y equals a number, okay? And I want you to see that my horizontal line of reflection is halfway between point A and point E. So I'm going to use the same idea. Point E is at 4, 3. So halfway between 3 and 7 would be y equals 5. Now, how did I get that? If I need to actually do those calculations, I could do 3 plus 7, which is divided by 2. Now, you may be saying, well, Dr. May, do they always end up to be the same number? And of course, the answer is no. But in this case, it just happened to, and I want you to see where those numbers come from. All right, my friends, I hope this helps you with your symmetry lesson for today. Have a great day. Bye for now.